welcome everybody. We're having an interesting room tonight for you, I believe, about Autonomy FUD. We have with us Warren Redlich, Sawyer Merritt, Omar Kazi, James Douma, and Emmet Peppers. None of them need any introductions. You all know them. If you don't, you can Google them. They're on social media everywhere. A little bit about the background. So Autonomy FUD, what are we talking about? We're talking about autonomous vehicles, of course, and FUD being an acronym for fear, uncertainty, and doubt. And there's been a lot of that for a while concerning especially Tesla and their full self-driving beta program. And basically, recently there was a podcast with a savvy communicator named Beth Kindig, and she was basically saying some stuff that made my skin crawl, and I think some of in the room here as well. And something happened also to Warren. He got the news recently, and he made a video about it. So I basically reached out and decided, yeah, we need to fight a little bit of FUD tonight, and they all agreed. And yeah, so let's kick it off. Emmet, I think you're the first one who interacted with that podcast from Beth Kindig. And can you tell us a little bit of context there?
Yes. My business is Good Soil Investment Management. My partner and I, Matt, do like a weekly podcast live and take questions from people. And someone, I think, asked us a question about, like, have you looked into Beth Kindig's comments on Roblox and Tesla? Those are like two stocks we talk about a lot. And so I was curious, and I hadn't heard of her name before, and I Googled her, and I think I clicked on the link for the podcast he was referencing. The person referenced it on Twitter or something. And I listened to it, and she sounded super smart on a lot of things. Like the first half of the podcast, I was listening to her talk about like NVIDIA and the chips, and like these are things I'm not an expert on. These are things I know a little bit about, but not much more than the average person, and certainly not as much as an expert on some of those topics she was talking about, technology related. And then it transitioned to Tesla, and there's people that have more expertise than me on individual things within Tesla, but I feel like overall I know a lot more than most people on, Tesla's elements that make it up. It's a huge conglomerate of technologies and businesses, as we know. And she started talking about full self-driving and that it needs 5G connectivity for edge case computing to work so it could be fully autonomous. And it just like set me off, and I was like, this is so wrong. This is crazy talk. I mean, and she's talking such a matter-of-fact way. Like, she's not talking like she's unsure. She's talking like she's very sure of it, which really, I think, was what bothered me. And so I realized that, there's a lot of, so-called financial professionals who are, sort of like generalists on a lot of things, and maybe that's what they're paid to be. And they're just being fed information from other people that maybe don't know what they're talking about half the time. And so you just can't trust a lot of people on this stuff. And so I think I tweeted it out, and then Warren kind of retweeted the clip, and it just kind of snowballed from there.
Yeah, so just to reiterate what the argument was basically like full self-driving cannot happen until 5G is implemented everywhere, because cars cannot do the computing on board the car because that will drain the battery. So they need actually to offload, and they can't offload to the cloud because those milliseconds, that extra that it would take to go to the cloud, would decrease the reaction times of the vehicle. So you basically need some sort of edge computing on the side of the roads where like the decisions can be made for the cars and transmitted back to the car for them to react.
Yeah, and she was talking about Tesla specifically too. She wasn't talking about, autonomous cars altogether. And she started off kind of like with a quirky comment, like she's been asked before, like, I don't know, have you driven in a robotaxi last year? Like, kind of making fun of Elon's comments about having robotaxi, like when the guy asked it. So she started off like very like she was very smart on the topic, and then she went into that, and I was like, what? She is way off on Tesla's autonomy. Like, it just was nuts. Yeah.
Yeah, what do you make of this, James? Like, do you have like insights why they're doing this?
So I actually, so I'm really interested in the tech, and that's what I spend my time on. I don't tend to follow a lot of these human controversies that spark. So her contention was that it sounds like from this context, like Emmet saying that her contention was that you can't possibly put enough compute in a car to do this. So the compute has to be somewhere else, and if it's going to be somewhere else and still useful to the car, it has to be close by, and it has to have a really, really high speed connection to the car. Otherwise, you're not going to have enough bandwidth, or the latency will be too long. Is that what she was saying, Emmett or Alex? You listen to her,
Yeah,
Alex? Was that her position?
yeah. I think in a nutshell.
Yeah,
Yeah.
that's
Okay.
exactly it.
So
And just
the I mean, so you can look at this from the standpoint of there are no extant robotaxis. There's no extant system which is level five. And then you can ask the question, well, why don't we have something right now? And I guess one approach you could say is, well, the sensors aren't good enough. Another thing you could say is, well, the computers aren't good enough. Another thing you could say is, well, the software is just not ready. And people in the space will disagree about these things. And when they, people who make forecasts about when this stuff is going to be available and what it's going to take to get there are generally extrapolating from their own personal experience, right? Most of these people are not they're not so deeply embedded in the space that they have these metrics that they know are reliable from first principles that they've tracked over a long time, and where they know exactly where it's got to get to in order for the system to achieve some particular capability. People in the space talking about self-driving cars have been wrong forever. I mean, and they're wrong in two different ways. You see people who say it's never ever going to happen, and that's just wrong. And you see people who say, well, it's going to happen in 2 years or 5 years. And every significant player in the space who's been around for a few years has been guilty of predicting it was going to happen sooner than it ended up happening. I mean, it hasn't happened yet. At the end of the day, we don't actually know the exact mix of ingredients that it's going to take to make it work. And all you can really do is you can pick a metric for, how well is the system performing, and you can watch how that metric evolves over time. And that's what you can do that's data driven. Everything else is opinions. So, if somebody comes out and says, well, you can't possibly do it with a computer, they're expressing an opinion because there's no first principles analysis that can lead you to the conclusion that it's not possible with a computer. So how much compute is it likely to take? Well, that's a really interesting question. You can kind of bound that problem by saying, well, how much compute does a human being use to do this problem? Or you can try to look at it from a kind of a more fundamental, how complex is the domain? What does it take to reduce this complexity to something that that becomes tractable for a computer? Those are all super complicated things to do. In reality, what we do is we build a system and we look at what it takes to make it get better. And then we make a guess about how much better it's got to get in order to do the problem. And that's what everybody's done up until now. That's what we're doing right now. That's what Google is doing right now. That's what Tesla is doing right now. And, people extrapolate forward based on reasonable expectations of what the hardware is going to be able to do within the window of time that they're talking about in order to get to these things. And the amount of compute that's available, in the window that we care about, like over the next couple of years, that you can put in a car and you can power off a car battery, is horrendously more powerful than what anybody is using today on these things. I mean, the algorithms can get quite dramatically more powerful than they are right now without stressing the hardware. So, like, if I was going to criticize robotaxis as an unachievable dream, I would not start with the computers, right? Anyway, so there's my, take on it.
Yeah, and
I would just say, if I can speak for a second, that it's striking to me. I talked to Jason Torchinsky of Jalopnik. I spoke with, what's the guy's name? Taylor Ogan. I watched this one, Beth Kindig. And what really stands out to me is you have these people who purport to be experts who say Tesla won't succeed because blah, blah, blah. And it becomes very apparent very quickly that they didn't watch Autonomy Day and they didn't watch AI Day. and if they did watch any of it, they didn't watch all of it. They didn't understand it. They don't understand basic concepts like, what to us are basic concepts, that the computer in the car is what James just referred to earlier as an edge computer, or that's an inference chip, and the computer at the home office is a training computer. And it's not that you refer back to the home computer to tell you what to do. It's not that the chip in the car refers back to the home computer all the information and then waits for instructions on what to do. The training computer trains the chips how to respond to whatever input comes in. And it's so apparent that so many of these critics just literally do not understand what's happening. And that's very frustrating. Like, if you're going to opine on whether Tesla's safe or not, or you should probably at least listen to what they said in events that were publicly available. Is it that much to ask that people actually listen and pay attention to that and try to understand?
Yeah, I agree. I mean, I think it's one thing for them to opine, but for them to, sound so sure of themselves as they opine, I think is misleading. And just as like a little anecdotal story, my dad, who's a pretty smart guy, he's the first one who told me about like self-driving cars in 2012, like being in the future, and I didn't believe him. I was like, no way. And then Tesla started talking about it. And, he's a very technology centered guy. He even owns a Tesla for the last several years. He doesn't follow the stock or everything about it like I do, but he's knowledgeable. He uses autopilot. So just like as a little anecdotal test, I didn't give him any context, any background. I just pulled up that 1 minute clip that you had tweeted, Warren, at dinner, like the next night, a family dinner where we had with him. And I was like, hey, Dad, would you do me a favor? Just listen to this 1 minute clip and let me know what you think. And he listened to it. And at the end, he's like, yeah, I think what she says makes a lot of sense. I agree 100%. And I'm like, Dad, you failed the test. So there's so many people that are like smart that if they don't study the stock and Tesla or whatever, what they're doing with AI Day and self-driving, they're just going to believe these people like blindly and be completely misinformed on what Tesla's capable of and their full self-driving.
Yeah, so a lot of things we've been hearing for years now is basically LiDAR, more sensors, recently 5G, edge computing, vehicle to everything, connectivity. And we have Omar here with us, who's been like FUD fighting on so many different levels, and he's an actual beta tester right now. So, what's your take on this whole situation? Is it bad faith from certain people, or it's just people that are not really in the know, and then other people exploiting those statements in bad faith?
Well, on the subject of this first thing we were talking about with 5G and that kind of thing, I mean, it's kind of silly that we're even talking about this to some extent. It's like talking about the sun going up and setting in the evening, because people say stupid things about autonomy every day, and especially about FSD every day. Otherwise respectable people who have a platform for some reason or another, people do not understand this, right? And it's, it's something that hasn't been done before. Nobody's ever made a fully driverless car that can work anywhere. And there's many, many people trying to achieve it. And so for some reason, everyone thinks they have an opinion on how a self-driving car should work. Even people who have no expertise, it's kind of like a very sensational thing in the public imagination, like a self-driving car. Is it going to crash? Is it going to kill me? So there's kind of like this appetite for it. But, really you have people saying wrong things like this all the time that are just so ridiculous. It's not even worth it to try and explain. But I mean, in the case of the 5G thing, if you have the system that's controlling the car and it's not in the car, it's somewhere else, you're essentially relying on a data connection to drive the car. And if there's any kind of failure in the data connection, you lose control of the car and potentially crash. So this is very unadvisable from a system design perspective. For, in case this should be obvious to people with a software background, but to others it may not be. And actually, there are some companies that are controlling their cars with 5G. Like there's a company in Vegas that they basically have remote drivers in their call center, and then they send a car to you, and it's quote unquote driverless. There's really kind of a person remote driving it. and then you get it, and you can then rent the car and use it, and then it goes back, quote unquote, autonomously to the call center. So there are actually some people trying this, but no network connection is completely reliable. It's obviously the wrong approach. What you want to do is run all the inference in the car, and yeah, I mean, at the end of the day, people are going to have to see it to believe it. And people will say what they're going to say. People are going to say a lot of wrong things. They'll say it's impossible. It's 100 years away. It's something that feels like magic. Like if you actually pull this off, a self-driving car that can drive anywhere, it's like you've pulled off a magic trick. And that's what I think is going to happen with Tesla. With my experience testing FSD beta, when people see this and see it mature beyond where it is today, it's going to be like Tesla pulled off a magic trick. Like they did something that people thought was impossible. And that's going to be really cool to see. We just drove across the country from California to Miami, 2,700 miles. We had about 16 disengagements, most of them being on the city streets FSD beta portion. With the Pure Vision Autopilot, maybe just 1 or 2 or 3 disengagements at most across the entire country. So this is incredibly powerful software, and nobody else has anything like it. Waymo, others, they can't cross the country. Their technology doesn't allow it. But Tesla's put it in real customers' hands. And when people see it,
Yeah, I got to say that one of her other arguments is that FSD would not be solved by a market leader today, but from some like small private startup, that they would actually win autonomy. I don't know what your guys' take is on that.
well, the problem with deep learning, at least the conventional approaches to deep learning that we have in our toolbox today, is that it tends to be fairly expensive, right? To train a neural network like Autopilot, you need massive, massive GPU clusters, let alone something like Dojo, like a custom designed chip. You need to buy massive amounts of graphics cards from NVIDIA. You need to have massive data collection, right? Think about Tesla's AT&T bill. Massive labeling team, right? These are people who are not just ordinary people. They need to have a fair amount of expertise in how to label the data properly. All these things are huge costs that make it difficult for a startup to take up some of the bigger players. Now, you do have Comma and some others who are trying, but you can take a look at, where they are and where Mobileye and others are.
I think that
it's sorry,
go ahead,
Warren.
go ahead.
So we have this interesting event in the recent up until 2012, the consensus was that neural networks didn't work and that deep learning didn't work. And this is a consensus that was almost universally held in the AI community. And that changed really radically in one day with one really powerful demonstration. And the external perception of this to most of the field, this came out of nowhere. I mean, everybody knew about this, and everybody knew the arguments for why it didn't work very well. Now, the arguments were flawed, but they were flawed in ways that people didn't bother to learn about, because the perception going back a couple of decades was that it didn't work, and because it didn't work, people didn't study it. So nobody, when it started working, people started looking at it a lot more closely, and the people in the field a substantial number of people in the field started to understand that they were under some misconceptions before. Not everybody has given up on the notion that it doesn't work, but year after year, it kept breaking these new barriers. That I mean, the AlphaGo thing was not. DeepMind didn't pick Go as a challenge problem just randomly. Go was a challenge problem because it was a long-standing contention in the artificial intelligence space that Go as a game was combinatorically insoluble. That is, the techniques that had been used to win computer games prior to that fundamentally couldn't apply to Go. And so it was this problem that was held out as an example of something that computers just weren't going to be able to do, that it took something like human intuition in order to play this game, because you can't solve it with the kinds of techniques that anybody had used in AI up to that point. So DeepMind went out and they went after Go. And what they basically were trying to show in a super general way was that what deep learning was doing was it was letting us do something like what human intuition does, like what the field had long understood, that you can't brute force Go because the problem space is too big. You can't go after it. So they beat that, and that was another thing along with Imagenet, where suddenly they were demonstrating that we had this new technique that nobody saw coming that just completely changed the playing field. And we're still in an era where there are people who kind of get it and they're getting on board with this idea that this technology has legs and it's really going to do a lot of stuff. And there's still a lot of holdouts that are deeply invested in things outside of what deep learning can do. Anyway, the point of this is that, so now recently we have a couple of historical examples of where suddenly out of the, I'm going to say out of the blue, which is not a fair characterization because all these techniques had been worked on for a long time. And then they suddenly crossed a threshold where they were good enough to do something. This is true of what they did in AlphaGo, and it was also true of Imagenet, which was the first event that brought this stuff in. But people in the field, they look at these and they say, well, why couldn't there be a third one? Why can't there be another, discontinuous leap forward? And there are a couple of candidates for great discontinuous leaps forward, which could make training neural networks suddenly dramatically more efficient. So people inside the field can look at this space and say, well, why couldn't it be some newcomer company? And you can look at these things and say, well, look at Imagenet, look at AlphaGo, and you can look at like AlphaFold is also another super groundbreaking. Protein folding is a problem people have been working on for decades, and it's a really, really important problem. A lot of smart people worked on it for a really long time. Nobody expected deep learning networks to be the thing that solved this. AlphaFold is capable of for 98% of the proteins that people look at of predicting the shape of that protein to within the measurement that it can be measured by state-of-the-art equipment today. And so that it's approximately solved in that sense, not for all proteins. And that's another thing that experts in the field, they didn't expect to see that for 20, maybe 50 years because people worked on it for a really long time. So you can look at all this stuff and you can think, well, maybe there will be yet another miracle. Maybe reinforcement learning is suddenly going to get dramatically better, or maybe unsupervised learning or some of those techniques, which we don't know how to do very well today. Maybe next week somebody figures out how to make those go, and that could happen. I mean, Tesla has the advantage of they got on the vehicle autonomy bandwagon after all of the other techniques, the earlier techniques had been running out of gas. As Google's problem is they're still highly committed to a set of techniques that aren't fully taking advantage of the latest stuff that we know. There could be something that comes next. However, I'd be shocked if the latest greatest technique came out next week and 2 months later Elon didn't say, okay, we're throwing all this stuff away, we're going to do the new thing, right? That they won't make the mistake that Google made of being unwilling to walk away from what they invested a lot in, which turns out not to be the way that it's going to go. So that could happen. It's less likely to happen than I think a lot of people might be hoping for. Like, for instance, Comma is very invested in this totally valid idea that there's a different technique called, it's another thing that DeepMind developed, which is this algorithm called mu0. mu0 is the underlying algorithm that did AlphaGo taken to its kind of logical conclusion. It's really inefficient right now. It takes phenomenal amounts of data, but there's no information theoretic reason why it couldn't be a lot better. And some people are thinking, well, we're just one breakthrough away from that happening, except for the fact that there are a lot of smart people who've looked at it and who've worked on it really hard, and none of the people working on it expect it to suddenly get dramatically better. So I would discount that for now. All of these things are possible. None of them are likely.
I get the feeling that you're saying that until there's like a trailblazer that actually hits on something successful, the space right now, the experts in the space are all like in agreement with each other, what is possible, what's not possible. And that Tesla, since we're talking about FSD being this huge, massive problem to solve, if they get to basically solve it, it'll be an aha moment for the whole community, the machine learning, AI, neural net community. They'll all go say, "Oh my God!" And it'll open a whole new universe to their way of.
You're saying if Tesla solves it, it'll be a big surprise to the people in the
Yes,
space.
and they'll actually start believing that other things might be also possible because somebody else has achieved it. Much like,
Well, I would say Kama already does believe that. Kama is, to George Hotz to some extent, he looks at what DeepMind did and he looks at these other, I mean, we've had a bunch of years now where really surprising things happened. The field, the deep learning field, I think it is not unreasonable to say that every year for 7 years, so much happened in the ensuing year that if you went back 12 months and you asked most people in the field, they would not believe what was going to happen in the next year. Like literally every year since then, we've had these events occur where something really surprising happened. That's not the same thing as anything is possible. It means a lot of the things that have happened are, I'm going to call them low-hanging fruit, in the sense that as soon as neural networks started working, suddenly there was this new approach to attack a whole wide range of problems, because it's a very flexible technique that can be applied to a lot of different problems. And up until now, it's been this free for all with people kind of running around just applying this technique to all of these problems, some small problems, some really big problems, and having varying degrees of success. That's different from a fundamental breakthrough. They're basically leveraging a breakthrough that we already had. Now, what Comma needs would be more, what Comma would need for Mu0 to suddenly become dramatically more sample efficient, which is its biggest problem, is that it takes too much compute. Like, there aren't enough computers in the world to make Mu0 solve the self-driving problem today. But, year by year, it becomes a more tractable problem because the techniques improve. I mean, the computers get faster, but they're not getting faster nearly at a quick enough pace. The problem itself is getting easier because people are learning more and more tricks. But that's different from learning a new trick and getting 20% better, is different from developing a fundamental new understanding where a whole bunch of things that you had no idea how to do before suddenly become possible. With Mu0, it's not a question of scale. They need something more fundamental than that to make it work. And so that's why I would argue that George Hotz is probably wrong, because we're probably not going to see that dramatic increase in efficiency. Tesla, on the other hand, is building what they're building almost entirely upon techniques that are known to work, and we know how well they're working. And Karpathy's approach has been, up until very recently, so I'm looking at the neural networks, I haven't seen Tesla try to do really novel things. I mean, every single ingredient that they put into the FSD system that I have been able to identify to date is something where somebody else figured out how to work and basically ironed out the details. Tesla took that new technique, they stuck it in their network, and then they cranked it up to industrial scale, and they took advantage of it. So they're looking at all of these researchers and all of these industrial labs and whatnot that are investigating how these things work, and they're cherry picking the best techniques from the best labs and integrating them. They're not doing research on their own, they're doing development. Because of that, they don't focus on trying to explore unexplored territory. What they're doing is they're scaling up stuff that's known to work. And if I look at that technique, I have to, it's a matter of scale. I mean, they've already looked at this stuff, and I agree with the assessment that the problem is solvable with the techniques they have if they just scale it up. Now, exactly how far it's got to scale, we don't quite know. But maybe it's a factor 2, maybe it's a factor 5. The techniques keep getting better and better. And, the exact date when all of these problems get solved is still as vague as it ever was. But you can see a clear path to success building on techniques that they have, and they've demonstrated a willingness to augment what they're doing with any new thing that somebody else finds, which is relevant to the problem. So they're not relying on a breakthrough. They're just scaling up stuff that's known to work really well. I mean, Karpathy stresses this when you see him talk about this. Like, they're not inventing new stuff. They're taking stuff that's known to work and they're scaling it up. So they will succeed. I think, there's little doubt. Because we don't know the exact threshold that you have to get to before everybody agrees that this works really well. It's hard to say exactly what that date is, but they're making really good progress on, and they will get there. Now, comma might succeed if there's a mu-zero breakthrough, right? They could get the advantage where they can suddenly, doing it with their garage full of GPUs suddenly becomes possible. But that's a lot less likely than Tesla just getting there. And if mu-zero does become possible, I think Karpathy would say, hey, let's do that. And then, Tesla would be taking all of the enormous resources they're already devoting to this problem, and they would make very rapid progress on it.
So why is, like, your view, and that this is just a scaling problem, why isn't this like the common view? And I'm asking the whole panel here, like, why is this not like the common view that we see like in mainstream media or from so-called experts or savvy communicators and tech analysts? Like, the only one I know of is basically like ARK Invest, that is basically actually seeing what James has been.
Because people who are critical of what Tesla is doing, I'll be short, Omar. People who are critical of what Tesla is doing simply do not understand anything that James just talked about.
Well, go ahead.
I think James brings up a really good point, which is, don't even bet on Tesla. Forget about Tesla. Just bet on the growth of deep learning. Because, most people who don't really follow software that closely probably don't know that much about this, but for the last decade, we've been undergoing a total revolution in how people produce software. Andrei Karpathy calls it software 2.0. And it really started, as James alluded to, with AlexNet in 2012, where there was a Stanford library called Imagenet. And Fei Li at Stanford, she just put out millions of images and what they were. Okay, here's a picture of a cat, and there's a picture, and there's a little text that says cat. Here's a picture of a dog, and there's a text that says dog. And she put out a challenge. She said, who can write a computer program that can correctly identify more of these images than anybody else? Because this was a problem that computers had never tackled before, right? Like, how can a computer take an image and recognize what's in it? It had never been done before. And there was a break. People generally at that time considered that deep learning couldn't really handle high resolution images, like maybe really low resolution images, but nothing more than that. It was just not enough compute to really tackle that. And then these guys came with AlexNet in 2012, 3 years after Waymo was founded, by the way. And they said, hey, well, we trained a neural network with the GPUs, and this let us get a breakthrough result on the Imagenet benchmark. And since then, really, deep neural networks have been blowing our mind ever since. Like, every year with these new kind of use cases that we couldn't have imagined before or thought were possible. The old kind of way of writing software was you had to provide a list of like procedural instructions to the computer. So, for example, if I wanted to, make lunch, computers don't make lunch, but I'm just saying in terms of the code, you might write, okay, first you need to open the fridge, then you need to take the bread out of the fridge, you need to take the cheese out of the fridge and put the cheese in between the bread, then shut the fridge. You really had to list out all the steps for how you wanted the computer to execute a task. But with deep learning, it was kind of just like, here's all this data that we've gotten from the internet and people, now using network computers on such a massive scale. And you search for the algorithm. And like Andre calls this software 2.0, you don't actually write the code yourself. You give it the data and help it figure out. So since then, we've seen, neural networks beat the best Go players, beat the best StarCraft players and Dota players and all these kinds of video games. amazing text to speech, right? I mean, we've all seen, speech to text in the last 10 years, where you can go on Google and, speak or translate, and it's just like amazing, right? For the most part. And, beyond that, like, GPT-3, they just said, okay, train it on the whole internet, then predict the next character. And so this approach has basically been, a total breakthrough for how we write software. And Tesla's going to be able to take advantage of the natural growth. Like what we know about deep learning today, in another 10 years and 20 years, we're going to laugh at how primitive our understanding was of how to build these systems where you train them based on tons of data. So let's say some kind of breakthrough approach emerged. Tesla already has a huge amount of data, a fleet that can allow it to collect new data if, it needs to be labeled in a different way. They can ship any kind of software they can imagine or any kind of idea they discover in the future to their fleet of existing cars. And I think that's really powerful. And the public still hasn't fully digested this. And I think that's really a lot of the hard part of what they have understanding is they're not used to something that updates and gets better.
If I can just address, coming back to the Tesla Q thing, I think this comes off Omar's point. I don't think they are going to understand what Tesla's deep learning approach is going to do or what any deep learning approach is going to do. I think we have to address, if we're going to confront Tesla Q, we have to address some of the common things they say and why they're wrong. So just for example, I tweeted this. I was driving home with my daughter today. And at this point, I was driving the car myself rather than having the car drive itself. And my daughter said it was funny that I had to have my hands on the wheel when the car was driving. There's a nag, but there's no nag when you're just driving the car. It doesn't remind you to put your hands on the steering wheel when you're driving. When a human is driving, then there's this misperception that, I forget who said this. Someone recently said this, that the car, I think it was like a regulator, was somebody from like the NTSB or something like that, was saying we can't just have these cars driving without somebody watching them all the time. Like, but that's exactly what what FSD requires, is that somebody watches it all the time. So there's a lot of misperceptions and misstatements about what is actually happening. So people think the idea is that people are with FSD beta are just hopping in the back seat and saying, take me to McDonald's, and the car just drives off. And that's not what happens. So I guess my big question is, what are some of the most common misstatements and how do we address them? One of my favorite things to say is that I trained two human driver betas, my daughters, to drive cars, and I couldn't really touch the pedals at all, and I had basically limited, if any, access to the steering wheel, while they were a menace to the society, arguably still are, right? Teen drivers are terrible. They have 10 or 20 times the accident rate of 35 to 50-year-old drivers. So that's an example to me of how we can confront the argument. Oh, it's terrible that Tesla's putting these, cars out in beta. We have beta drivers all the time. They're just human beta. But what do you guys feel are strong counters? What some of the most common objections that people raise to FSD, and what are some of the best answers to those?
I want to mention one thing. There's an entirely different category of FUD, which comes from people who actually do have reason to claim to be expert in the space, which is different from super basic misconceptions. And you probably have to approach those from a
Yeah, on some level, I feel that maybe it's because like neural nets are some sort of like black box, or maybe because people don't realize, the technology has sneaked up on them and has become like ubiquitous, like translate, voice to text and stuff like that, that maybe they don't realize. And it feels like maybe FSD is like somebody coming out tomorrow and saying, well, I'm working on a warp drive or something. And, we haven't even like mastered like just going to space with reusable rockets yet, like fully reusable. And now somebody comes out, like the leap is too far in people's psyche. Do you think that could be a part of it? I'm not talking about Tesla Q who are doing this out of bad faith, but maybe those so-called experts or experts in the field, they can't stretch their imagination to those.
Lack of imagination on the part of the general public, like I think that explains a lot of stuff. And certainly there are very few people who are as interested in this as the Tesla community is, right? Like my dad is he doesn't have a Tesla yet. I'm trying to get him into one, but every time I have the silly things that Warren mentioned, like I run into with my dad all the time, really basic misconceptions that he gets from headlines of whatever newspaper he's reading, and that's an issue that I don't really know how to go at addressing. There's this other thing that I would like people to understand, because I think it gets left out, which is I when AlphaFold. So AlphaFold, just for anybody who doesn't know what it is, like DeepMind did a deep learning based protein structure search system that basically would predict the shape of a protein from the DNA code, essentially that describes it. And this is a long-standing problem that dates back about 50 years that the biomedical community has worked on with great fervor, because it's considered a really, really important problem and not made a lot of progress. So I was reading the blog of a fellow who works in this space and had worked in this space for decades. I mean, he'd been working on this problem because he thought it was really important, and he had a whole lab full of people who worked on this problem with him. And he was one of like 20 different labs. And he was describing when he saw the results from AlphaFold, like essentially solving this problem using a technique that's completely different than anybody in the field ever thought about applying to it, and something like he personally didn't know anything about. And he described like his stomach, like feeling butterflies or feeling like he was falling because they had invested so much for so long. Like he had built his whole career around doing this stuff. And while he was delighted to see the problem being solved because he thought it was really important, he found himself having this kind of aversion to the fact that somebody else had come in and just solved the problem. So deep learning is getting that kind of pushback from experts in a lot of fields who are sort of feel like they're being run roughshod over by this new technique that's coming out and solving problems that they built their career around. And that's an important component of the FUD at the expert side of things, that, there are a lot of people who have worked on a lot of these hard problems who are basically saying it can't be that easy, and who are pushing back on it. And you can't easily dissuade them. They're in the space where they just have, unless they're going to spend time to learn the new technique, they're going to have to get used to the idea. They're going to have to see enough examples of the technique actually working before they're going to believe that it actually displaces all the expertise that they developed over so many years to do this kind of stuff.
Yeah, I'm just reminded of the recent tweet from Senator Richard Blumenthal when we're talking about the safety, and I'll just read it. Tesla is putting untrained drivers on public roads as testers for their misleadingly named unproven system, a seeming recipe for disaster. Serious safety concerns should be put this reckless plan in reverse. It's Russian roulette for unsuspecting drivers and the public. And of course, he was quote tweeting Laura Kadlani. And I got to say, this ties up to Warren, but this statement is like provably false. Like, for example, Omar has been driving and has had a driver's license and has been on the road. And I would bet that he pays more attention when FSD beta is engaged than when it's not. And a lot of people who are going to have the button and clicking the button and maybe soon getting to be FSD beta testers, they will have to have a score of 100 to basically be. So these are safe drivers that are going to pay extra attention while supervising a system. I don't see how we could say that this is more dangerous than having teenage drivers, student drivers on the roads or on, temporary permits or stuff like that. What do you say to that, Warren?
I, no, I just, really simple. If Senator Blumenthal believes that, then we should not allow ordinary parents to teach their children to drive cars. We should only allow people to learn to drive cars from trained professionals who are trained to teach people to drive. And the practical reality is I watched Omar drive across, I should say, I watched FSD Beta drive across the country with Omar supervising. And Omar's sitting in the driver's seat. He has access to the pedals. He has access to the steering wheel. When I taught my daughters to drive, I did not have access to the steering wheel. I did not have access to the pedals. And I would say, in a sense, Omar is probably better able to predict what the car might do wrong than a parent would be able to predict what their child might do wrong. It's hard to see. What I would notice from teaching my children to drive is they don't see the road the same way we do, which is kind of different. The FSD Beta sees more than we do. Children might look at the wrong things. They might not realize where they're like focused on staying in between the lines, right? Which is easy for FSD Beta. They're not looking down the road to see, wait a minute, is that bicyclist coming out in the road? So I actually think the task of supervising FSD Beta driving is easier than the task of teaching your child to drive a car. For those two reasons, you don't have access to the controls, and it's harder to predict what your kid's going to do wrong. Does that make sense to you, Omar?
Yeah, I mean, I think that's completely right. It's a lot easier. You have a view into what the car's thinking with the visualization. It's a lot more predictable. You get to know the software and to preemptively disengage. I think that it's easy enough for the average person to do it, right? And it's really only going to be a few years that people need to watch, maybe as little as like a year or two, maybe as much as 5 years, but it's really only going to be a few years that people need to watch it. And then it's going to be so good. The reliability level is far excessive of a human. And then it'll actually get to the point where the human having control actually makes it less safe. And that's when you'll start to see models emerge, with the wheel removed. But generally, I think a lot of this confusion is really about partial autonomy, right? And people don't understand partial autonomy, full autonomy. Where does it all fit in? And I think what people really don't understand is, look, Google announced their self-driving car project in 2009. It's now almost 2022, right? We're talking about like 12, 13 years. And have driverless cars really launched in any meaningful scale? Not really. You can go to Chandler, Arizona, and you can take a Waymo within the geofence, but you can't even take it to Phoenix. So self-driving cars have not launched at a meaningful scale where it actually makes a difference in people's lives. And people say, hey, I'm going to sell my car and I'm just going to take these autonomous cars everywhere, and that's going to eliminate the risk of a crash or dramatically reduce it. That hasn't happened. So the question really is, okay, how do we get lots and lots of automated cars on the road as quickly as possible? And Tesla figured out that, or they came up with a strategy that the way to do that was partial autonomy. And you're going to use the existing cars on the road, and you'll start to ship whatever features you can. They've been doing this for years with traffic control, with the active safety features, with Navigator on autopilot, with all these things. And now they're launching even more features that can basically, in some cases, completely automate a drive from parking lot to parking lot without you having to touch a thing in terms of disengagements. That is starting to be possible in some cases, right? So it's going to take some time to get that more reliable. And people kind of go, well, how is it full self-driving if I need to watch it? And it's like, look, when you buy, what you're buying from them is full self-driving. They're not going to keep the old versions around and make you buy a new version. When you buy it, you buy the whole thing. because it would be unsafe to keep old versions around. So every update that comes until it is truly driverless, you're going to get that if you pay for the full self-driving. But today, it is not an autonomous car that you can sleep in. Right now, it's at an early stage where you have to watch it, you have to be ready to take over, and you should expect to have to take over when it does things wrong, and be ready for that. And in fact, the cabin camera is actually going to watch you and make sure you're paying attention, make sure you're not using your phone, make sure you don't fall asleep, and respond appropriately if you do. So I think this is a lot of the confusion. A lot of the critics are dishonest and they want to have it both ways. If a drunk driver slams into somebody and crashes into them, they want to blame autopilot. Well, what about the fact that the guy was drunk, right? That doesn't matter. It was autopilot, right? It was all autopilot's fault. But then at the same time, they want to say, okay, well, it's just a level 2 system. So they want to downplay it as just a level 2 system when it's convenient. But then if there's a drunk driving death or something, then they say, well, it was obviously autopilot to blame. So I think a lot of this is really not understanding that, guys, we've gotten nowhere on autonomy for a decade. Okay, more than a decade. Is it going to be 2 decades? Here's the path forward. Partial autonomy. Starting to ship these features to people today and to continue to ship updates to make them better and better and better until they're driverless in some places and situations, and then driverless in all situations, places, weather conditions, all of that. And that's what we're going to as really people continue to train the system. So I think that's really what people are struggling to understand, the difference between partial and...
I just want to ask James a question. I think a reasonable position that might make sense is to say, you know what, we won't have the cars driving, we'll have them run in shadow mode, which for those who don't know, the human is driving the car is watching, the car is making predictions, the car is deciding what it would do and then sees what happens. James, is there a reason why that's not sufficient for FSD to develop into genuine full self-driving?
It'll take longer. I mean, there are a lot of different ways you can go at these problems, and Tesla, like my sense of is that Tesla has opted to do things the quickest way that they can, and within the reasonable resources, and keep.
Interesting. So we have had callers very patiently waiting in the queue. So let's take a few questions. Dimitri, you're up. Just unmute your mic, Dimitri, or we're going to go to Rob. Okay. Rob, you're up. Rob left. All right.
Well, let me make a pitch here really quick for those who didn't. Something that happened earlier, the reason I think I was invited to the panel was Beth Kindig made this statement criticizing FSD, saying, you couldn't do it in the car or whatever. She made these nonsensical statements about FSD. And that irked me, and then somebody else said something that irked me. And for those who don't know, my daughter's friend was run over, was in a crosswalk and hit by a car, and the driver said that he did not see her. And I believe, I wasn't there, but I believe having now a small amount of experience with FSD, that the odds are that a Tesla with FSD in the same position, would have seen her soon enough to brake at least enough to not kill her. And I've made a video about this where I got somewhat emotional because I remember this girl. I videoed her dancing. My daughter, she was in the same dance class as my daughter. And I'm very upset about this girl dying. And and I want to see if you guys disagree with me on this. There's 1 million people a year who are killed in car accidents. And if we shift to a world of all self-driving cars, then we eliminate nearly all of those 1 million deaths. And so if it's 1 million a year and you delay the advent of self-driving cars by a year, you've killed 1 million people. And the complaint in the video that I made recently, the concern raised by the Tesla Q people is, autopilot has killed 10 or 20 people. Well, if auto and that's over like a 4-year span, and it really turned out that 20 was really 10, and I don't even concede the 10. You're talking about maybe 2 people a year killed by autopilot. You're ignoring the number of lives that FSD saves, which is probably more than the 2. But you're comparing that to the potential, if you delay self-driving by 1 year, you kill 1 million people. And I think people have trouble grasping that. Does anyone on the panel, or maybe we should go to a caller, but I just wanted to stress, this is why this is so important to me. And I think this is why this should be so important to everyone, is we want fewer people to be killed by cars. And if we get FSD to where it will be soon, which is 360-degree division all the time, never falls asleep, never gets sick on drugs, never gets distracted, all of the things that a lot of the human errors that cause these accidents are gone. That's why I'm so motivated. Obviously I'm a Tesla shareholder. I wanted to work as a Tesla shareholder, but I'd really like to not have children die. I don't think that's crazy. So sorry.
Warren,
Yeah.
Warren, I agree with you. This is Emmett. I totally agree with you 100%. And this is sort of like the higher calling here. It's not about the Tesla stock. It's not about the Tesla brand. It's literally saving lives. I mean, car accidents, I think, is the 3rd leading cause of death after like cancer and heart disease. So if you can almost eradicate that with the advent of full self-driving a few years sooner than otherwise would be, that's a huge win for humanity. And so, yeah, that's really the higher calling. I think a lot of these, journalists need to kind of consider when they're writing their clickbait articles in the coming year or so on the first full self-driving death that will inevitably happen. It's going to be a media frenzy, and it's really going to be sad that it could potentially delay the advent of full self-driving.
Comment on the media frenzy thing, that because this is so the self-driving cars, people have been working on them for a really long time, and incidentally, Warren, that argument that you just cited about rapidly developing full self-driving capability being essentially measuring the cost of delay in terms of the number of people that die per day, that was something that Chris Urmson used to say back when he was still running Google's auto. You don't hear Google say it very much anymore, unfortunately, because they opted more and more over time for absolute safety as opposed to rapid progress. I mean, I would contend that people on that team, they disagree with it, but I would contend that they sacrificed getting there quickly, on that basis. And part of the argument that they made for moving slower than they had to, because they wanted to be absolutely safe, was what Emmet just mentioned, which is there's this fear inside the business that got voiced a lot in the early days, that we need to really do this well, because if we mess it up, the public will reject it, and then even more people die, because that delays the rollout of this life-saving technology. But in the ensuing years, we've seen people die in accidents involving cars that have varying degrees of automation, and the public really hasn't responded. I mean, if you look at the public responding in ways that actually matter, that ways that would actually delay the technology, it really hasn't happened. That would either require them to demand regulations, like people to demand regulations, not media blowhards to demand regulations, but people to actually ask their representatives to do something to delay this technology, or it would require changes in consumer behavior where people rejected these technologies. And what we've seen over time is that, despite the fact that there have been bumps in the road, the adoption of this technology is rapidly expanding. I mean, the consumers have, voting with their dollars are accepting this more and more. And even though there have been, accidents that got super hyperbolic media treatment, there really, aside from the occasional grandstanding senator, there really hasn't been any regulatory pushback that was unreasonable. I mean, the NHTSA investigating accidents, that's not unreasonable, right? This is a new phenomenon. This is their bailiwick, and that's what they're supposed to be doing. if they start moving to regulate the technology, then we'll have some evidence that things have gone too far. And I would argue that there's no evidence so far that the public is rejecting the technology. So I don't understand why we keep assuming that the public will. I mean, inside the field, that's something that it's become a mantra. You know, it's just been repeated so many times. It's become true that you need absolute safety because otherwise the technology will get set back. But, you know, I look at all the other safety systems that we have, you know, I mean, my favorite example is airbags. Airbags killed a lot of people before they got good, and they still kill people every year. And you don't see the public rejecting airbags because they're imperfect. So I don't see why we should believe that the public, I'm not talking about the media or people who are in the business of scaring us all, but that the public actually doesn't understand that a system, you know, that saves lives, that works really well but isn't perfect, is something that they should refuse to allow.
Yeah, I agree. The public, for sure. I think they're smarter than politicians even think. But I just think, you know, like the media, who's in the business of getting people to click on their articles about FUD, fear and rust and doubt around self-driving, they're going to push it. And then I think there's going to be people like Senator Blumenthal and lobbyists who are in the ear of Biden's administration, you know, all kind of pushing to delay it, you know, to kind of set Tesla back if possible. I'm not saying it will happen. I just think there's a certain probability there you can't ignore. And, you know, we'll see how that probability goes over time. But it's certainly a possibility that it gets delayed through some kind of regulation pushed by lawmakers, you know, which is sort of like the Boeing, remember the Boeing 737s or whatever, all grounded for like years until they figured out this thing, you know, like what if there's like one autopilot death of like a kid being run over by a self-driving car, it's on video and it's put on the news and people are like, be careful about watching this, it's going to upset you, and it gets people emotionally upset, and then it's enough for the political folks to kind of seize a little power and say, hey, we're going to stop this until we can investigate further, you know, and then it could be like a investigation that takes who knows how long, is my opinion. But that's in the US. I still think it'll come out, whether it's Norway, China, or whatever. I think it'll still come somewhere before the US, even if that does happen.
You know that some of the sort of most sympathy-worthy airbag victims were babies, right? Like babies and small women were this class of people that were getting killed by early airbags. They didn't have the capability to change the amount of the deployment force, and so they calibrated the deployment force for a medium-sized adult. And so if you had a small child or a small woman or a baby in the seat, it would kill them. And there were a number of super gruesome accidents as a consequence of this. They got a lot of airplay, and the public still, you know, they didn't.
Yeah. No, I remember discussions of people saying we should outlaw airbags, sort of like, you know, other political discussion, but never took wind. And there was a possibility that airbags could have been delayed or outlawed temporarily until it was addressed, but it didn't happen. But I'm just saying there's a possibility now that something could happen to Tesla's full self-driving getting delayed. I'm not saying it's probable or it's going to happen, but there's certainly a significant possibility that can't be ignored in my mind.
I think there's also a distinction to be made. Like airbags, yes, they're a life-saving system, same as safety belts, but they're not cool, for lack of a better word. Whereas I think everybody that thinks about the future wants a self-driving car.
Alex, do you want?
Yeah, let's give the callers a chance. Okay, so I'm going to bring you up. You just have to unmute and start speaking. So next up is Emoji Guy. You're up. What's your question, comment?
Hi, I've got a question for James in regards to the interview with Dave Lee and George Hotz. And George had suggested that robotaxis were at least 8 years away and that Tesla hardware was limited in terms of the cameras and the sensors were a couple of generations behind. Do you think that, you know, this is a problem that can be overcome quite easily And does Dojo really change the picture on this?
James, if you're trying to
Okay, so I feel James is maybe otherwise occupied. We'll come back to your question, emoji guy. We're going to take the next caller.
Thanks.
Sarek, you're up. Sarek, you're up.
Oh, hey, sorry, I was on mute. So I have a question related to quantum computing. As far as I understand, right now Tesla is mostly using like deep learning and approach like to solve the full self-driving. What about the quantum computing for solving the like full self-driving technology? So I just wondered, on using this technology. Thank you.
Anybody want to field that question? Because the simple answer.
So quantum computers are very much, nobody has really built a quantum computer that could start to try and tackle some of these problems in a meaningful way. So, we're a ways away from quantum computing being relevant to autonomy.
Yes, I'd have to wholeheartedly agree. So let's take next caller.
I just wanted to say the app crashed on me and I had to log back in, so I missed a minute or two.
Okay, so we had emoji guy asking about the interview with Dave Lee, and George Hotz, where George Hotz said basically that full self-driving was about 8 years away, and that Tesla's hardware was lagging behind like a few versions to what was like currently being used. So he wanted you to comment on that.
And what
specifically,
impact
James.
Dojo would have.
Yes, and what impact? Yeah.
It's an interesting assertion. Comma's hardware is way behind Tesla's hardware, so it seems kind of strange to suggest that Tesla would lose on the hardware front. And Tesla's hard. I mean, Tesla is they have an application accelerator. They built an FSD chip. Everybody else in the space right now is still using GPUs, and GPUs work. They're less ideal for the application. Comma AI is using a SoC with a GPU in it, and GPUs are maybe 5x less efficient than application-specific ICs at doing this kind of stuff. So I'm not sure where George was coming from on the hardware criticism. Maybe he was talking about sensors, but once again, so Comma's latest system has higher res cameras, but they have a lot fewer of them, so the actual pixel density of the field of view is a lot lower. So that would also be a weird criticism for.
They're basically
George
running on an Android.
Yeah, well, I mean, it's an Android phone on steroids now. The Comma 3 has got a lot more power than any recent Android phones. But yeah, it's a powerful Android phone, and they use 280-degree cameras to try to get 360 coverage. Although they have to look through the infrastructure of the car to do that because it goes where the rear view mirror does, and then they have one narrow camera in front. You can come up with criticisms for the hardware of anybody doing this. You can come up with criticisms of Tesla's hardware, and theoretically you can. But I don't know,
Anyway, I'm seeing that emoji guy who asked the question is next in line after the current caller, so maybe he can elaborate. Little, you're up. Just unmute your mic. Little, you're the next caller. Okay, we're going back to emoji guy. Emoji guy, you want to follow up?
Yes, I think George was talking about the actual sensor in the camera, saying it was a couple of generations ahead of Tesla. And I think I watched an interview with Emmet and one of the FSD drivers, and he said he had some concerns about the B-pillar cameras being only able to see 80 meters, and whether that's going to be a problem going forward for Tesla.
Yeah, so George is right that the sensors that he's using right now they're more recent generation than the sensors that Tesla's using. So they're higher resolution and they have higher dynamic range. Now, once again, in the particular case of comparing Comma and what Tesla is doing, that's a really bad comparison because Comma has one sensor facing forward, one sensor facing backward. They're HD sensors, so they have like 1 kilopixel horizontal, but it has to use that across the entire front of the car. Whereas, Tesla's got like 5 cameras looking forward. So even though the individual sensors are lower resolution, the aggregate resolution of the sensors is a lot higher. Comma's also got somewhat higher dynamic range, but that only matters if the dynamic range that Tesla's got is insufficient. And at least from the frames I've seen coming out of the cars, I mean, the cameras, the sensors that Tesla's got in their car, they were designed for this application. I mean, they have a dynamic range, which is appropriate to self-driving and is probably sufficient. That's not to say that they won't. Newer sensors, better sensors come out all the time. I'm sure they'll add better sensors at some point because, better is better. Let's see. The other thing was the sensor question. What was the second one? Can somebody remind me?
It was, and with Dojo, if you were to just, finger in the air, give a prediction for when robotaxis are live, what would be your sort of prediction on that, given what you know now and AI Day has come and gone?
Yeah. So that's always a fraught question because it depends on where you draw the line, right? Is it level 5? They can go anywhere. I think they start being useful in a year. They're already useful to some extent. You can, if you have AP in your car right now, it's really relaxing. It'll probably be a year before FSD is that kind of relaxing. Before the cars are driving themselves, it's that kind of time frame. But my disclaimer there is that I've said we're about a year away for the last couple of years. So I've been consistently wrong about that, as have a lot of people in the space. But I persist in believing that we're getting really close. It is the kind of thing that you're not going to know until you cross the last line because you never. Elon has mentioned a couple of times about getting stuck in a local minimum or a local maximum, which is that this reference this idea that you're getting better and better and better, and then you get kind of stuck for a little while. You stop getting better, and you have to look at why you're not getting better and come up with some resolution to that. And so recently, getting the radar out of the car and going to pure vision, that was in response to them hitting what they thought was a local max. Now, if they don't hit any more local maxima, they're like a year away. But then we don't know if they're going to hit another one in between there and encounter another delay. But a lot of people in the space want to argue that they're like some of the most famous people that comment on this topic are arguing 10 years and 20 years kind of numbers. I have a really hard time believing that we're 10 years away from being able to tell your car to go park itself in the garage.
I just want to say something about this. Being a fairly new Tesla driver and having just yesterday or the day before yesterday driven, or I should say letting FSD or Navigate on autopilot or whatever drive me for several hours, when I got to the last supercharger station before coming home, something glitched in the car. I'm pretty sure it was because I enabled an app called Teslafy, which I will never use again. I don't know for sure that it was that, but I think it might have been that. The FSD didn't work, the cruise control didn't work, and I had to drive the car myself. And I was like, well, this sucks. All of a sudden, I had to drive the car myself, and it's like, damn, I like when the car drives. So, it's really, really good. It's really, really, it's not perfect. It makes mistakes. You have to watch it, but it's really, really good. And I think we're going to go to version 11, which is going to be one stacked rule. And Omar and I disagree about this. He's got a lot more experience, so you should listen to him over me. But my sense of it is that a lot of the interventions are either nav related or they are at the moment or at or near the moment of switch over from one stack to the other. And if you go to one stack for everything, I don't know if everybody understands what, maybe James could explain one stack to rule them all. But to me, the transition from stacks is a potential problem, and the nav integration with FSD is a potential problem. James, can you comment on can you explain to the audience what one stack to rule them all means and what it means to switch between?
So a stack is all the layers of the perception and planning system that basically operate as a block. They're built in these modular layers, and when you put all the layers together into one configuration that you're driving with, that's called a stack. Right now, Tesla, the last time I checked, they had 3 separate stacks in the car, and one of them seemed like it was for city streets, one seemed like it was for highways, and one seemed like it was for parking lots. So the advantage of having multiple stacks is you can more quickly get good at parking lots if you're only thinking about parking lots, and you can get better at city streets if you're only thinking about city streets. So you get a training advantage. That is, an individual stack within its domain gets better quicker. But then you have the problem of deciding when to switch from one stack to the other, because one of the things, parking lot stack will be a lot better at parking lots, but it's going to be really bad at streets. So when you make the transition from, like, say, being on a city street to a parking lot, and you have to make the decision about switching, if you do the decision wrong, if you're driving your city streets in a parking lot or your parking lot in the city streets, you have problems at these transitions. So getting to a unified stack is challenging from a training standpoint. Like building a single stack that's as good as parking lots in the parking lot and as good as streets on the street and so forth is more challenging. It takes more data, it takes more training time and more hand tuning. But once you get there, there's all of these categories of problems that you eliminate.
And I just, the other thing I wanted to ask you about is, like, just one example, we're driving to a supercharger, which is, I think, a gas station, a Wawa or something like that. And there's a very clear entrance on the main road that we're on. But for whatever the reason, the nav says, go past that, make a left turn, and turn in at this other entrance, where it turns out that there's a barrier between lanes, so you can't really make the left turn that the nav is telling you to make. So I don't know whether Omar counted that disengagement, but that was a disengagement that wasn't really the fault of FSD. It was the fault of nav or the way the nav interacts with FSD. Does it make sense that, can FSD take over the nav part too, or is that fundamentally a nav issue that, the maps have to be better at telling you where the correct entrance is? I think there was at least 2 or 3 of those incidents where, the nav put the entrance, like, drove us like 50 feet past the entrance and told us to turn left when there was no entrance.
Yeah. So the perception system, it's tasked with identifying relevant features in a particular context and trying to understand the context. So it has 2 things that it kind of has to get better at. One of them is identifying the thing you want, like drivable space, for instance, or where another car is. And the other thing it has to get better at is understanding the context that these decisions get made inside of. So at a certain level of context ability, it needs the map to be pretty accurate, because if the map says, this driveway is the driveway that I want to take. Well, a human driving along might look at a particular driveway and understand, well, that can't be the right driveway because it turns into the wrong kind of parking lot. I'm going to a grocery store and this is a driveway. As autopilot gets better at understanding what it sees in context, the constraints on how good the nav system needs to be to get acceptable performance, those get relaxed. In the long run, the nav system will stay largely separate. Like, there will always be a big chunk of the nav process that isn't getting done inside autopilot, although little bits of it might come in, the very localized bits of nav, which is where it's just handling the navigation within within what it can see right now. I think we're really unlikely to see nav, for instance, try to figure out, like, the shortest distance between your house and your work, because that problem is already really well solved other ways.
Yeah, so we have callers again. Max, you're up. Unmute, ask your question or comment.
Yeah, thanks, guys. Yeah, this quick question is, how will the long tail problem will be addressed? That's the question.
Did anybody catch that? Could you repeat?
The long.
Yeah, so the long
Oh, the
tail
long
problem.
tail.
The
Yeah,
education.
okay.
Yeah, well, it's you have to get enough nines that you can provide functionality that people want. You never get the last nine. The nines, so the system gets better exponentially, and nines is an exponential measure. So in a weird way, you get more nines in linear time. It doesn't take exponential time to get exponentially better because the system itself improves exponentially. So my short answer to that is that even though the march of nines is intimidating when you think about it mathematically, the fact that the system improves exponentially makes the march of nines a tractable problem. It does make it hard to predict exactly, like, how many nines do you need? Do you need 7? Do you need 9? Do you need 11? What is the right number of nines? We still don't actually know the answer to that. So that's a march of nines problem that is going to persist for a while. But the system will solve the march of nines in linear time by getting better exponentially.
And can I just ask you about that, James? One of the things that we just saw is that they're expanding FSD beta, which I believe means they will be able to take in more data. And recently, maybe 2 months ago, Karpathy said they had added a third supercomputer. So is it possible that one of the reasons they're expanding the beta is because they now have more compute available so they can process more data? And by having more data and more compute, that speeds up the exponential growth?
It's so I think that there's a misperception baked into the way that you're thinking about it. So I'm going to attempt to correct that, and then you tell me if I got it wrong and misunderstood your question. But people tend to think of the fleet as a recording device that basically it goes out in the world and it captures data in proportion to how many cars there are. And the fleet, it's better to think of the fleet as a search device where Tesla can say, I need this situation to make my algorithm better. I need examples of this, and then they ask the fleet, and the fleet goes around looking for these things, and it only records the things Tesla asked for and sent them back. So what a bigger fleet gets you is not more data necessarily. It could get you the same amount of data in less time. Like if Tesla says, I need 1,000 examples of this particular thing to solve my problem, a bigger fleet that's looking for this stuff, naturally, it would be able to do that quicker. But the important aspect of the fleet is that it's that you can ask for specific things, and you get just that data back from the thing. So they don't actually end up with more data because they're always asking for just the data that they need to solve the next problem they have. As the fleet gets better, gets bigger, they can work on more problems simultaneously, and that's useful.
Well, yeah, but I mean, you said earlier that if they only ran in shadow mode, you would still be able to find examples of things in shadow mode. There's something that they get out of the car the FSD driving the car that they don't get out of just observing and looking for things. What do they get out of the vehicle? That's why I was thinking
Warren, they're not expanding the beta because they added another computer. That's just not really how it works. I already tried to explain this to you once, but I think fundamentally when we talk about the March of Nines, it's really kind of like, okay, the team can send out queries, like they can send out a little neural network and say, find me something like this, like James alluded to. Or, you can imagine them going to the fleet every day and saying, hey, what were the top 5 disengagements? Give me information about all the disengagements that happened. And theoretically, we have some kind of maybe AI or manual process to classify these errors as, what is the class of problem, why they're occurring, and classify all these disengagements. And let's see generally what are the top reasons people are disengaging. And maybe the first day it's, okay, well, left turns where you don't have a good view, and it's, people are disengaging because a car is coming, and the car didn't see it or something like that. So, okay, let's fix this problem. So then they fix this problem. And then you work down to maybe a more rare kind of problem. Like, okay, well, really snowy days. It's having problems with really snowy days. So you might send out a trigger and say, okay, give me more footage of really snowy days. So you tackle that problem. And then as time goes on, you keep getting weirder and weirder problems like, you know, the hill was on fire and the air was really smoky in a way that's very unusual, or there was a group of 1,000 people running through the street in a chicken suit or something, and this set it off in some weird way. So as time keeps going on and you keep working through, and the fleet gets bigger, you're basically gaining those very, very rare cases where it doesn't work. It already works in all of the normal cases, but the very rare cases where it doesn't work are just getting more and more and more rare. And because all of the other disengagements have been, eliminated or perfected, you then start to see those really weird cases and can start to improve on them in ways that makes the system even more reliable. So basically, they just call it churning the data wheel. That's how we'll handle the long tail events. Just keep churning the.
I would agree that the impetus for expanding the FSD program was not that they had increased computational capacity, because like they don't use all the data they have already. They cherry pick the data. I think the driver for expanding the FSD program was just FSD getting good enough that they weren't worried about negative consequences if they added a lot.
Okay, so let's take the
Exactly.
next caller, Ricky. You're up.
Hey guys, the basis of my question, may be a statement, is kind of building on that, the Martian Nines, and I guess I'm kind of wondering how fast it could happen. I work at an accounting firm. We're not public. We mostly do private companies. And maybe about 3 years ago, we had a partner walk in, and he was almost lividly angry because he went to some conference with a bunch of other firms, and they came back and made a statement, and they did a comparable audit to us, and probably about 50% of the time. And it turns out that they were using a piece of what they call AI software at the time. I wouldn't really call it full AI. It was just grabbing the low-hanging fruit. And so we picked it up. And over the past 3 years, at first it actually took more time to get something done because we were implementing the project. But then as we used it, it became smarter and smarter. And I mean, this past year, we almost did an audit in a year, an audit in a week and a half that prior had taken us a month and a half with twice as many people. So I guess, does anybody else have that feeling that it could get to a point where maybe we are even underestimating exponential growth? I guess I would also kind of agree with one of Omar's earlier statements about partial FSD, because that's kind of how we approached it. We took little pieces that we understood and became more comfortable with it and trusted it over time, and it helped us reach that full potential of what we're using it for now. So I do see that as rather than going after full safety.
Yeah, people who have had that experience of like watching the software, watching these techniques get better and suddenly cross a threshold where it affects them. I had the example earlier of the researcher who worked on protein folding, who, he knew this stuff was in the background and he'd heard about it for years, but he didn't expect it to happen. But then there was that day when suddenly it was good enough to do his job. So it seems really sudden on that threshold. Yeah, that's how the March of Nines happen. There will be a day when it's good, when people agree that this is good enough to drive a car, and it's going to seem really sudden because 6 months earlier, a year earlier, it still looked like it was really.
Okay, G, you're up. Caller G, you're up. unmute your mic, ask your question or comment.
Oh, hi guys. My question is related to what's your view on the deployment of FSD worldwide once the first acceptable version is reached in the US. But I'm from Brazil, and different infrastructures, traffic rules, and then the way I see it, the neural nets are used mostly for perception, and the driving is hand coded mostly. So do you think that is going to be a easy flow to deploy it all worldwide, or it would require a lot of work for Tesla and other companies? Thanks.
Yeah, great question. The intention is definitely to deploy it worldwide. I mean, a lot of the kind of strategic design decisions they took in the system are informed by not wanting to be in a situation like Waymo and some of the other players are, where you have to really pre-map an area with LiDAR to be able to localize your position accurately. And that's really, the foundation of your driving. They really wanted to make a system which, in theory, you can just look at any road anywhere in the world and it does the right thing. And they've tried to design the system to work with multiple driving policies. So, as an example, I just crossed the country with FSD. And here in California, when the carpool line has a solid line, you can't change over. You have to wait until the line is dotted. And FSD knows that. It won't cross a solid line, even if I ask it to. And then when the line is dotted, it'll cross over. Now, when we cross the border into Arizona, the road markings are a little bit different. They have a solid line, and you can cross the solid line to get into the carpool lane. That's what you're expected to do. So once I crossed the border, it knew that. And we've also seen these guys in Ukraine who got FSD working on their car. They kind of hacked it together, and it was able to work in Ukraine, right? So it already has an EU driving policy, and they've actually been testing it. There have been job postings for like Paris. There's people in Canada testing it, even people in China who are Tesla employees doing early testing. So the intention is definitely to launch all around the world. The reality, of course, is that there's even differences between San Francisco and Los Angeles. In theory, it should be able to work. In reality, it is a lot of work to tackle all of these regions and to handle all of the idiosyncrasies of all the regions in the world. It's really like a decade-long project to kind of get to that level of reliability in every corner of the earth. So I think you're going to start to see it in bits and pieces, one step at a time. And I think they're not as far behind as we think in other regions. If they can get this to work in the United States, they've built a very, very strong foundation for themselves to launch it in other.
Yeah, there was that video dropped in Ukraine of those hackers or something that got a version of full self-driving, and it was amazing to watch. It seemed like pretty serviceable in Ukraine with all different language, different road laws and such. It was pretty cool to watch if you guys haven't seen that.
Yeah, on the planning thing, the planning is going to go into the neural network. It starts out heuristic because it can. Perception can't start out heuristic, but the planning will go to the neural network, and it'll probably go to the neural network before FSD is widely used. And then the other comment, look, you need more localization the weaker the system is. As the system gets better, localization matters less. By the time FSD is really good, it won't require a lot of localization. Like when it's good, it'll be good everywhere. And when it's poor, it'll be better in some places.
Yeah, Andre actually likes to say that the kind of holy grail is a system that just takes in the camera inputs, and the outputs of the neural net are the steering wheel, turning angle, and the acceleration pedal application and the brake pedal application. So all of these kind of driving rules would somehow be internalized into the training data in this kind of holy grail system that we don't quite know what to build yet. So that's definitely the direction they're kind of slowly going to. If you hear some of what he says about the autopilot team. When he started, it was a lot more procedural code, a lot less deep learning, and over time, the deep learning has started consuming more and more of the procedural software 1.0.
Okay, Sarek, you're up.
Yep. Thank you. So I have a question regarding the pricing for like robotaxis. And Elon, he mentioned at a few of the interviews that the price will be taking the robotaxi will be cheaper than taking a bus. And I mean, I took a taxi, a Waymo taxi in Chandler, Arizona, and the pricing was exactly the same with the Uber and Lyft. I compared the pricing. So, do you think like when this technology will be like released, so will the price will be start like from the similar price, or it will start with like half price, like $1 per mile, or even it will go even to lower, like over time? Or I mean, if the price will be decreasing over time, or it will be kind of cheap from the beginning? Because like based on my calculations, like the cost of owning like a car with 1,000,000 miles that Tesla can drive, it can drive up, I mean, the price will go up to like 21 to 22 cents per mile. So yeah, it will be great to hear your opinion on this. Thank you.
So let's put this in perspective. Uber and Lyft, they've been operating for a number of years. They've never turned a profit, right? They're not profitable. They're losing money, and they don't even own any of the cars. All they're doing is running an app that matches people who need a ride to people who can offer a ride, and handling all the background checks and other infrastructure in between, taxes, yada yada, and local regulatory issues. And they're losing money. Now, Waymo has the same money-losing business that some of the smartest people with shit tons of venture capital have been pouring money into Uber and Lyft for a decade, and they haven't even been able to make it profitable. So Uber inherits that shit show. But on top of that, they own all the cars, which cost somewhere on the order of $250,000 to $400,000. They're painstakingly manually assembled, right? They make the car, then they gotta disassemble the car, then add on the sensor suite. So they are losing money offering rides at the same price as Uber and Lyft. And the issue with that is, they really need to be charging more because the car costs more. But, at the same price where Uber and Lyft can't even make money, they need to charge that and own the car. So the unit economics of that system are pretty bad. And that's why it's kind of relatively expensive. It's the same as Uber and Lyft. And even with that, they're burning $1 billion a year. So you really kind of need a fundamentally different approach where, you have millions of cars and they are truly driverless. And it's a fairly kind of commodity, sensor stack that can be mass produced, right? You can build the best self-driving car in the world, but if you can't mass produce it, then it's not worth much. So I think the price will come down to the point where it's pretty much free for anyone to take a ride. But the kind of approach we started in 2009, the spatial approach, as some call it, is not really going to get us to that breakthrough price.
Yeah, I would just trying to address specifically what I think the caller may have been going for there was when it starts, you will not have enough robo-taxis to serve customers at, say, 25 cents a mile because the demand would outstrip the supply. You'd need to have millions of robo-taxis ready to go in whatever market you're talking about, because the demand for robo-taxi rides at 25 cents a mile, which I think will be the eventual price, if not lower. So initially, you take the Bay Area and you introduce 100,000 robo-taxis in the Bay Area, and you would lower the price below what Uber and Lyft charge. So let's say Uber and Lyft charge an average of $2.50 a mile. It's probably more than that, but call it $2.50 a mile. And pricing isn't so simple as per mile. We'll call it, to simplify that. So maybe they introduce them at $1.50 a mile, and the pricing would probably be adjustable based on demand. Because if there's what you don't want when you're running a robo-taxi network, on the one hand, is you don't want the car sitting there doing nothing if your price is too high, and you don't want customers waiting too long for a ride if the price is too low. So initially, it's going to be I think probably demand based the whole way through, that there'll be some flexible pricing, but it probably starts closer to what Uber and Lyft charge at the beginning, but undercutting them. And then over time, as you add more robo-taxis to an individual market, you're able to lower prices so that the robo-taxis aren't sitting there doing nothing. And I hope people can see that balance. You can't charge too little because then people will be waiting too long for a ride, and you can't charge too much because then the robo-taxis will be sitting idle. Does that make sense?
Yeah, it totally does. And I just want to check in with our guest speakers and our hosts, because we were planning to do a 1 hour room and we're at like close to 2 hours. So are you guys want to take a few more callers, or are we calling it a night? What are your thoughts on that?
I can do 20.
Emmet, you good to go? Warren?
I can stick on a little longer. If I have to drop off, I'll just quietly leave, but I can stick on for a little while.
I'm good for whatever.
Yep, me too.
Omar, you good? All right, so let's take another caller. Ricky.
Just a quick dreamer question, maybe to figure out my level of geekdom. How many other people have thought ahead, if this is actually successful, what roads might look like in 20 years? Like, do you guys actually think it would start to change, like barcodes on signs and flickering lights or something like that?
I've thought about it every day for 20.
And what have you come up?
Yeah, that's not a short discussion.
Okay.
I only have
Future episode. What do the roads look like in 20 years?
I would just say that one of the things we already know that's coming is that the roads are going to go underground, that we're going to see a network of boring tunnels. I would say typical city the size of Las Vegas will have 100 miles of tunnel, and there are 1,000 cities like that. So we're going to see a lot of roads go underground, which is going to reduce noise pollution, reduce other pollution, reduce pedestrian deaths even more. And we may see some roads converted to green space. And then the other question is, if you go far enough in the robotaxi world and you end up with single passenger robotaxis, which is perhaps my fantasy, and maybe I'm wrong about it, and they're 3 feet wide, then you've doubled the capacity of a lane. And if they follow each other really closely because they communicate with each other, you're probably increasing the capacity of a lane longitudinally as well as laterally. And so you may get a lot more, you may be a lot more efficient with your road space.
Absolutely. Actually, when you started talking about the tunnels, it reminded me that I went back and watched that movie AI, and I was blown away that they had like tunnels everywhere in their cars. And that was before any of that was even under concept. Gotta love.
Yeah, and I actually think that the 3-inch wide car that increases the utility of roads. I've heard that argument before, Warren. I think you're a little bit biased on that aspect.
Yes, I'm very biased on that aspect.
All right, we're going to take the
Hey,
next
Alex,
caller.
real quick, can I ask a question of a
Yes.
couple of the panelists as if I was a caller? I would like to, yeah, I would just like to ask Warren and Omar, did you guys drive together for that 1,600 miles? What was that like, being in the same car for so long? Did you guys get along? What...
Omar was great. Omar sat in the driver's seat the whole way. I thought we got along remarkably well. My biggest irritation was my brother rather than Omar and K10, who were wonderful people. And my brother is a wonderful person, but he's my brother, so naturally he gets on my nerves.
Well, yeah, we got along remarkably well. It was kind of something I was thinking about, like, okay, sometimes people fight on these road trips or whatever, just being around each other so much, you get on each other's nerves. But no, everyone was in a good mood. And, I think autopilot just made it so easy and comfortable. Like, just thinking about, like, if we had to cross the whole country without autopilot, someone had to drive, we had to take turns driving, oh my God, it would have been a nightmare. So, we talk about, oh, when's autonomy, when's the robotaxis coming? But, this car did, more than 99% of the drive. It was completely automated, right? And that happened today,
Cool.
right? So it's pretty mind-blowing to
I think you calculated it, right? So you calculated disengagement and you gave each disengagement 1 mile and you came up to 99.6, I think, percent or something like that.
Yep. Right. Yeah. So, I mean, each disengagement was probably like a few 100 feet, and then I just turned it back on right after. But, if you assume, let's call each disengagement 1 mile of manual driving. And some of the, like, one of the disengagements was like 4 right next to each other because of a construction where the road we had to go to was blocked off. But anyway, let's just be super liberal about it and say, so 2,700 minus 16 over 2,700, that's kind of like the percentage of the distance that was completely driven by the computer. It was more than 99%. So, this is real. This is happening. And it's already something that we can't live without, as like Warren was alluded to. I've had those times where it's like a bug in the Tesla and like autopilot doesn't activate for some reason and you have to drive manually and you're like, fuck, this sucks. And I think people are going to get addicted.
Yeah, I just want to really quick mention that particular disengagement Omar is talking about, we're going towards Austin after getting off I-10 on 290 East in Texas. And the road was blocked off. And Google Maps was telling, I was checking Google Maps while we were doing it. Google Maps was telling us to go through this road that was blocked off. So I don't know what would have to happen for FSD to be able to figure out, wait, this road is blocked. I have to find another way to go. And then ask the nav which other way to go when the nav doesn't know that it's blocked and doesn't know how to find another. Like Google Maps did not know how to find another way for us to go. I had to wing
They're
it.
going to end up building a lot of mapping technology themselves, probably. And, really the vision system needs to identify, I cannot proceed. I need to reroute. It needs to be able to find an alternate route and, do that. It's not really at that level of advancement right now. So basically what I had to do is take control, get it back on the right path using my own judgment of how we could arrive there without going through the roadblock. And then I turned it back on and it actually did the rest pretty well. So, these are the kinds of things that need to be worked on. But, today, it did most of it. And tomorrow, yeah, it needs to be able to do that too. Even if a road is closed that you thought you were going to drive on, you got to find a different way. It needs to be that, you're taking a nap and it's so good, it can even handle that and go find a different route. And you wake up, you don't even know that there was.
Nice.
Okay, so next caller, back with dubious emoji guy.
Hi, I just want to know, are there any significant risks with autonomy not being solved? Are there things, and are we waiting on significant breakthroughs that may not be achieved within the next sort of 5 to 7 years? Or is it now just the inevitability and we're just sort of waiting on time and, the next 5 years almost guaranteed?
In my opinion, it's an engineering problem. They'll keep turning the crank, it'll keep getting better. And at some point they cross a threshold where it's good enough to, provide even more value to people than it does today. Eventually it's good enough to drive the car by itself. And we all agree that that's okay. And down the road, it gets better and better. Breakthroughs could accelerate it significantly. I wouldn't, it's hard to know about breakthroughs because they're breakthroughs, but they should be able to just turn the crank on what they've got right now. And
Yeah, I just want to address this one thing that I hear people using the term level 5, and I think we ignore the fact that many humans are not really level 5. So just for example, my daughters are afraid to drive on interstate highways. And FSD is perfectly happy to drive on an interstate highway. So I think, or I should say autopilot, navigate on autopilot is perfectly happy to drive on an interstate highway. I think we need to recognize that it can be better than human in a variety of situations without being quote level 5, which is I think an archaic concept. I don't know if anybody has any comment on that. I should just shut up. I'll shut up. Alex, are you there?
Oh, sorry, I'm muted. I was muted. Sorry. Praveen, you're up. Sorry. Unmute your mic.
Oh, hi. Good evening, everyone. I had a question for James. James, I appreciate everything that everyone's doing in this community. James, I wanted to especially thank you for the interviews you've been doing with Dave. And I think a lot of us are getting a ton of value from this. I wanted to touch on one of the interviews that Gally had on hyperchange with a few others in the, I guess, the machine learning space. I think it's a video that's titled AI Day, when he talks to James Wang and someone named Naveen Rao. And Naveen kept bringing up the fact that from his, I guess, vantage point, when he was watching the AI Day presentation, he didn't seem that impressed from what Tesla was, presenting about Dojo, and he kept talking about how Cerebrus' system was, orders of magnitude better, or at least significantly better. So I was wondering if you could kind of touch on this. I know you kind of mentioned something in your last interview with Dave about how maybe the capabilities of Dojo were being underestimated because Tesla was maybe sandbagging a little and only talking about the off-chip bandwidth, if I'm getting the terminology right. So just wanted to ask if you could kind of touch on this.
And so I did I think it was the last thing that I did with Dave, and we talked about this in a lot of depth when we talked through. In fact, I talked about it in so much depth, he ended up editing about half of it out and putting it in a separate video. I think I did watch that, and I think Naveen's comments were basically his hot take based on just viewing AI Day. So I don't know if he would necessarily feel the same if he actually sat down and like tried to work the numbers out to figure out like what would map well onto this and how would it compare for the problems that Tesla's doing relative to other platforms. I was myself pretty surprised. I mean, it looked to me like in a lot of ways it was more straightforward than it turned out to be when I started getting down into the details. I don't know if I would say Tesla sandbagging so much as I think it's easy to underappreciate what they're doing if you don't like sit down and run the numbers. And after I did that, I was a lot more impressed with, and like I was pretty happy with the system to start with, but I was a lot more impressed with the system when I sat down and I started thinking about how it would affect the particular types of things that Tesla wants to do. Did I answer all of your question?
Oh, yeah, absolutely. Yeah, thank you for that. So I think, did you mention that parts of what you had answered may have been edited to maybe be included in another video with Dave?
Yeah, so Dave, he has a link. If you watch the first video, I think there's a link that he put in the comments to the full unedited version of the video, which is longer.
Okay, all right, perfect. Thank you.
I mean, it'll be great for going to bed.
Oh, come on. But I know which video you're referring to, Praveen, the Gally interview with the two other guys. I don't think he was saying the Cerebrus was like orders of magnitude better. He was, I think, more commenting on the fact that the headache that Tesla was, tackling by doing it in-house may not have been worth it because Cerebrus, in his mind, was pretty much equal to Dojo. So he was looking at more as a CEO of a company that he would have made like a different decisions. But I think this is an ongoing story with Elon where, they vertically integrate everything in-house and the payoffs are not immediately foreseeable by most, but long-term, it makes so much sense.
Yeah, the Cerebrus system, it's pretty impressive for how it's scaled out. Like they can do a lot, but the Cerebrus system, it's built on an earlier fabrication node. So their one wafer is about the computation that Tesla gets in one tile of Dojo. So if they want to scale, and it turns out that their off-chip bandwidth is actually, I was shocked when I actually looked up the numbers. It's really terrible. Like the Cerebrus system is basically designed to work really well on any problem that you can fit entirely on a single wafer. Tesla's system will scale to problems about 100 times bigger than that. So, as soon as Cerebrus wants to get, Cerebrus, they've got a great system. It doesn't scale the way that I think Tesla wants their system to scale. There's a reason why they built that fabric as big as they did.
Thank you so much.
Okay, we're going to take the next call. Oh, go ahead, Omar.
Yeah, I was just going to say, having like a lot of people are going to do a lot of great things in this space in hardware. I think NVIDIA, others are building great hardware. But Tesla designs what they need, right? And they design exactly what they need. And that's a really powerful thing. So when you look at the FSD computer, for example, you have, an NPU, neural network accelerator in the hardware that can speed up inference a lot. But you also have things like hardware accelerated, H.264 and H.265 video encoders, an image processing unit that can do things like lighten the image and remove noise and do some kind of like hardware-based pre-processing that is advantageous to the neural network, which then can get better data downstream in real time. And even things like the security module, which ensure that all the updates are cryptographically signed and haven't been tampered in some way. So it's others may at times have systems that are better in some ways or have a more impressive spec in one regard, but Tesla's not stopping with this one computer. They've got a world-class chip design team that is going to make a next generation and a next generation, and they're going to continue to design what works really well for them. And that's really powerful. This level of vertical integration, it's unheard of. Everybody else, they've got a partner, 2 partners, 3 partners to try and pull off a self-driving car. Tesla's doing it all themselves. And if you saw like the windshield video they posted on YouTube recently, they're even tweaking the composition of the windshield to make the autopilot system work better. Now that is a level of vertical integration that is unseen anywhere else.
Yeah, great point. So we're going to take one last caller. We've just hit the 2-hour mark. So Rajendra, you're the lucky last call, and unmute and ask your question.
Hi guys, great discussion. So I have a question that is sort of a general nature. So looking at the progress AI and neural nets have done in the last 10 years, it's pretty clear that the capability of FSD and AI is going to improve exponentially. So apart from technology, what are the biggest obstacles to see self-driving cars everywhere? I mean, is it public perception, or is it that the regulations and laws have to change, or something else? Thanks.
The biggest obstacle is always government, but I'll yield to everyone else on the rest of it.
So what do you guys think? What's the biggest obstacle for mass adoption of full self-driving?
I still think my background is the tech. I think if we had it today and it was working well, and the statistics showed that it was working well, that regulators will get out of the way because their job is to make the public safer. And even though they might be inefficient, they still know that that's what their job is. If we had it and it was working well, I think people would accept it, and it would probably ramp about as fast as we can produce the stuff. We'll be manufacturing limited for quite a while after the stuff comes out. There's a really big fleet of cars. So I would answer that I think the technology is basically a problem. When it's really good, I think it'll see the adoption.
And just a little follow up on that, like Elon always comes out with like 1,000% better, which is 9 times better than the average human driver. Do you all have the same feeling that this is what is necessary to get regulatory approval, or something lower or something higher?
I think
Well,
when the statistics are super clear, then I think regulators will be moved by it. There's, you can slice the pie different ways, and so the statistics can be unclear if your advantage is only, say, a factor of 2. Critics or skeptics could still come in and they could frame the question a different way and make it look like you're not actually doing much better. But even at the same level as a human being, it's got a significant amount of utility. I would agree that, like, if you get to 10x, then the game is over, because there's almost no way to statistically misinterpret a 10x say.
Yeah, I have
Omar?
to agree with James. I think that, for everyone shaking their fist at regulators or encouraging regulators to do something, regulators have been pretty supportive, at least in the United States. At the end of the day, NHTSA understands, they get it. They get that a technology like this has the potential to save people's lives, not just in the future, but today. Just the other day I was driving on FSD and I was stopped at a red light, and I was just glancing down at the visualization, and I saw a little pedestrian stick figure guy walk from the sidewalk, walk up to the side of the car, and then was standing right next to the car, open the door to the car and get in, and then shut the door, right? And I saw this all on the visualization, and heard sounds that confirmed what I suspected was happening. So I never looked behind me. I was looking forward at the traffic light, but I could see this stuff happening behind me because I had this kind of extra AI eyes in the back of my head that were assisting me. And that goes for the active safety features too, and even the autopilot we're driving. Like, regulators have already allowed this to exist. We went to Chandler and we rode in a Waymo. So I think the regulatory thing is often kind of used as like, oh, but will the regulators allow it? But the fact of the matter is, like, the regulatory situation has been pretty good so far, and I think it's just a matter of the capabilities. And in terms of the capabilities, it's an inevitability in my mind that cars are going to be self-driving, and that this current software is just going to evolve to be better and better and better. It's just like, you can't cut the perfect build once. You can't just magically put out a piece of software that's just perfect. It takes a lot of trial and error. You got to put something out, and you got to see, like, okay, what is it doing? What is it doing good? What is it doing bad? And you have to have a process of iteration to arrive at that perfect build. So we're in that process right now. We're churning the data engine, and we're on the way there. Now, can anyone say for sure what the date is going to be where there will be robotaxis in any area? No. And people have been wrong guessing again and again. But I've been running this on my car for over a year now, and it's inevitable. I'm convinced.
Okay, so on this final note, I'm going to thank our guest speaker, James, Emmet, and Warren, for their generosity with their time and insights. Really appreciate you guys coming on. Also thanking Sawyer and Omar. And we're going to be closing out the rooms and putting the episode up both on this app and for Android users on our YouTube channel. This will be done tonight, and we'll be putting out highlights tomorrow. Thank you all for being here.
Thank you, Alex.
Thanks, Alex.
Thanks for having me on.